Yo, what's up guys? Welcome back to another AMC8 video. Today we'll be covering the hardest problem on the AMC8 that was arguably the hardest ever given. This is problem number 25 from the 2024 exam. So let's get right into this. A small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among these seats. A married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? Okay, so let's address this question. So this question was one of the trickiest on the AMC8, especially because by the time many people got to this problem, they didn't really have more than a few minutes left, and this problem is very, very tricky. So, first of all, what is it asking us? It's asking us how many ways can we arrange the couple so that they have 2 seats next to each other. So, for example, highlighting some possibilities, they could sit here, right? Let's say there were 2 open seats here. They could sit here, or maybe here, or maybe here. You get the point. So, that is after 8 passengers board. So, how can we find these combinations? Well, the key is looking at the answer choices first, which might seem counterintuitive, but it's the best way. You can notice that all the answer choices are above 50%, right? A, B, C, D, and E. So this makes us notice that we should use complementary counting. Now, what is complementary counting? It's basically counting the possibilities that don't work and then subtracting it from the total number of possibilities. So that's what we're going to be doing here. So here we can use casework, or looking at different cases where there aren't 2 adjacent seats. So the first obvious case is where we'll look at empty seats, okay, not occupied seats, because then we only have to deal with 4 empty seats. So representing empty with E, the first case we could have is an empty seat in every row, right? Because then the couple has to sit in different rows, so they're not together. So how many ways can we do this? Well, it's just about choosing how many ways can we choose, it's 3 times 3 times 3 times 3, because in every row we have 3 choices for empty seats. So 3 times 3, or we can just do 3 to the power 4. That's going to be 3 squared times 3 squared, which is 9 times 9, which is 81. So let's track our possibilities here. So 81. Then what can we do? Well, the other case we can have is have 2 empty seats in 2 rows, such that the passengers cannot sit next to each other, or the couple cannot sit next to each other. But how can we do this? Well, the only way there's 2 empty seats in a row and they can't sit together is they're on opposite ends, right? So essentially what we're going to do with this case is find how many ways out of the 4 rows can we choose 2 rows to have empty seats like this. Well, that's just going to be 4 choose 2, right? Because we have 4 rows and we're choosing 2 of them to have this configuration in. So that's just going to be 6, right? Because this is nothing but 4 factorial over 2 factorial times 2 factorial, which is 24 over 4, which is 6. Okay, so we got 6 here. So let's write that here. Okay, and the final case we have, this is by far the trickiest case, is if there's 2 empty seats in one row, right? Like we just discussed in our earlier case. But then there's 1 empty seat in 2 other rows. So how can we find this probability? How many ways there are to choose 1 row out of the 4 rows to have 2 empty seats like this configuration? Well, we can just use common sense here, right? We have 4 rows, choose 1 row, we have 4 options. So 4 times, remember, we always do times when we're doing combinations. Okay, and then the question that remains, let's say we choose this row for 2 empty seats. We now have 3 possible rows in which we can choose 1 empty seat per each. So how would we calculate this? Well, first of all, how many ways are there to nominate 2 of these rows to have 1 empty seat out of the 3? Well, that's just going to be 3 choose 2, right? We have 3 seats out of rows, And out of them, we choose 2 rows to have 1 empty seat. But remember, we also have to multiply this by 3 twice. And you may be asking why. Okay, let's just say we choose an empty seat in this row, in this row. There's 3 possible choices for each empty seat in each row, right? It can go here, here, or here. So every time we put in 1 empty seat in a row, we multiply by 3. And since we're doing that 2 times, we multiply by 3 2 times here. So what is that going to be? Well, 3 choose 2. That's just going to be 3, right? So this is the equivalent of 4 times 3 times 3 times 3, which is 4 times 27. Let's evaluate that over here. That's just going to be 108. So, I can erase the question. So 108 possible choices for that case. So plus 108. Now all we have to do is evaluate this. So let's do this in a different color. Can use this. Equals 81 plus 6, that's going to be 87 plus 108. And 87 plus 108, that I believe is going to be 195. Yep, it's going to be 195. So now, remember, we did complementary counting. So, first of all, what's the total number of cases we can have to arrange 4 empty seats in 12 empty seats? We need to find the total possibilities because we still haven't done that. Well, that's just going to be, let's do it down here, 12 choose 4, right? We have 12 possible seats, and we need to nominate 4 of them to be empty. So 12 choose 4, that's going to be 12 times 11 times 10 times 9 over 24. And the 12, 24, and 10 cancel out. 10 becomes 5, 24 becomes 1, and this becomes 1. So 5 times 11 times 9, that is going to be, let's move this over here. Right? 5 times 11 times 9, that's going to be 495. So now, remember, we have the 195, 495. Right? So we subtract, so our denominator is going to be 495. And from the total cases, we have to subtract the ones that don't work, which is 195. So 195 minus 495, that's just going to be 300. And let's say we divide by 3 here. 165, right? And then if we divide by 5, we have 20 over 33, and this is the most simplified it can be. And sure enough, in our answer choices, let's do this in one last color, we have answer C, 20 over 33. So the key idea in this problem is to first notice, see what is the question asking us. That's basically any question. But the key realization is that all the answer choices are above 1/2. So to make our life easier, we can do complementary counting, or counting the cases that don't work, so we can more easily do less work to find the same answer. It's just using this casework and complementary counting that we can get a smooth and easy answer. So although this was tricky, we ended up solving this in a pretty simple way. So if you have any questions, leave them in the comments and I'll be sure to answer them. So smash that like button and I'll see you guys in the next one.